Hello, Colin from Juniper. Quick one today. I'm going to talk about setting up a routed interface that has VLAN tags, and in the specific case, coming from a customer question that I found myself too foggy in the head to answer. Forgot I take an allergy medicine earlier in the day. Uh, Having an untagged interface, sub interface, and then tagged interfaces. So we're going to go walk through that, and we're going to walk through testing. We're even going to verify with a packet capture, because ultimately this particular customer is going to put this in production. I want to make sure that this configuration is doing exactly what we think it's going to do, not just in config, but also on the wire. So let's cut over to our lab, and you'll see I've got a pair of VMX hosts that are already set up and powered up. We'll get into each of those, and I'll put the one on top console here, and I'll put the one on the bottom's console below. And then both the interface, I'll do a show command. This one's got FXP, this one has nothing. So we've already got our links set up here. We're obviously, switch that over to the arrow. We're using GE00. So we're going to first set up a normal, just routed interface to test connectivity, verify that works, and then we'll go back in and we'll change it and add in the config that we need to both add VLAN tags and also have a sub interface that is not tagged. Now, if you're looking at the description above, you'll see I'm using the terms IFD and IFL. IFD refers to physical interface, IFL refers to a logical interface. That would be the unit numbers, the subints that we have. So let's just start on this router on the top here. We'll do a set GE000.0 family, inet, address 10.0. Let's do 10.1/24. Great. And do the same here with .2, set GE-0.0 family inet address 10.0.10.2/24, commit, and run ping 10.0.10.2. We see our pings working. Make sure it works in both directions. All right, no problem there. So the first thing we're going to do is we're going to take this router on the top, and we are going to add some VLAN information, and we're not going to make a change to the router on the bottom, because remember, if that one VLAN that we're interested in is untagged coming in, then this should still continue to work. So we'll get into the interface first, and one of the considerations here, well, there's two. First, we have to enable VLAN tagging to start with. Then we need to change the unit number so it matches the VLAN ID that we're going to assign. That is a requirement. So I'm going to set up flexible VLAN tagging. And I'm not going to get into that. You can Google what that means and why you would use that instead of VLAN tagging. For my use case, this is with a customer who's using MPLS. It might also be required when you have both tagged and untagged IFLs, but I'm just using it because it's easier than, that way you just kind of cover all the bases beyond just using the VLAN tagging command. So that allows us to set VLANs. I'm just going to rename unit 0 to unit 10 because I'm going to use VLAN 10. So that's just saves me some typing. I'll set unit 10 VLAN ID 10. Oh, 10. Now, if I were to commit this, these pings would stop, right? Because I haven't done anything to tell this router that that is an untagged VLAN. So you can see the pings there at the bottom died. So what I need to do is I need to do set native, set native VLAN ID 10, and I need to commit that. And then you see the pings pick right back up. So at this point, I've got this working, and I have an untagged VLAN, even though I have VLANs enabled. And I'll just add a couple other sub interfaces as well, and we'll make sure that ping doesn't break when I do a commit, and then we'll create a complementary configuration on the router on the bottom, and then we'll look at what it looks like on the wire. So, in fact, maybe that's just something fun to do right now. Well, we'll get through it first. Edit interface G0. So let's do set unit 20 family inet address 10.0.20.1/24, set unit 30 family inet address 10.0.30.1/24, set unit 20 VLAN ID 20, set unit 30 VLAN ID 30. Now we'll commit this. Obviously, there's nothing on the other router that's going to make that work, but we want to make sure that this continues to function okay. And the reason I'm doing these extra checks is that when I implement this in a production network, unless I'm down to the second coordinating the config on both ends of the same link, I want to be able to commit this configuration change on the one end and still have the existing traffic work. I just, the other VLANs aren't going to work until I actually have them enabled on the other side. But in this use case that I have for my customer, we only have that one, that one subnet that's currently connected. So everything else is additive. And this just ensures that we don't break it when we start that process. So let's add those here. We're just going to create some complementary configuration down here. So I can do copy, edit GE000, rename unit 0 to unit 10, set flexible VLAN tagging, set native VLAN ID to 10, set unit 10 VLAN ID 10, set unit 20 VLAN ID 20, family iNet address 10.0.20.2, and set unit 30 VLAN ID 30, family iNet address 10.0.30.2/24. Show commit run ping 10.0.10.2, 20.2, and 30.2. Perfect. Let's take a look at what this looks like on the wire. So I'll just right click this, do a capture on GE00, Ethernet. We'll start by running the ping across the native VLAN. We'll stop that. And we can see here that we have just a normal Ethernet frame. And I want to draw your attention to the length here of 98. That'll be important, particularly if you happen to be doing any kind of VPN or encapsulation. This could be MPLS or something similar. Now I'll ping to one of the VLAN subnets, and we'll see those come across. And you'll see that we've got 4 extra bytes for the VLAN information. That's totally expected. And if we look at one of these packets, we'll also see that the .1Q has been added here for VLAN. And we can see that that is on VLAN 30. So there you have it. It works, verified. We can see that there are no tags, and even the 4 bytes is not there for the VLAN when we have this in an untagged mode. So this should work. There's no special consideration between vendor, at least there shouldn't be. And to be honest, if you're pulling untagged traffic, that VLAN ID that you're using on either end could really just be a throwaway VLAN. You just pick one that you're not using anywhere else, because really what you need to do is just define a VLAN just so that you can have the configuration take, because as soon as you enable flexible VLAN tagging, then it's going to want a VLAN ID for each of those IFLs that you configure. But it's not going to really exist beyond that unless you start creating a bridge domain and bridging interfaces together. If you have any questions, put them in the comments. Hope this has been useful, and have a great rest of your day.